All right, so for today's notes, we're going to continue looking at normal distributions. Last class, we were talking about standard normal distribution. Remember, that meant your mean is always 0, your standard deviation is always 1. We're going to look at things that are not standard normal. So, when we talk about things here, we're going to be working with still normal distributions. They're just not going to be standard normal. That just means the mean is not 0 or the standard deviation is not 1 or both. However, remember, we've already figured out how we can find a z-score. So we can always convert something from a normal distribution to a standard normal distribution so that we can use the methods that we've already learned. So what we're going to be doing, right, is we're going to take our data from our non-standard normal distribution, use our z-score, and then that puts it on a standard normal curve. So let's go ahead and look at an example of how we would do that. So assume that the weights of men are normally distributed with a mean of 72 and a standard deviation of 29. If one man is randomly selected, what is the probability he weighs less than 174 pounds? So last class we could find the area, right? This is what we're looking for here. We want to know the area of this shaded region. Well, last class we learned how to do that on a standard normal curve. So we learned, right, if our mean was 0, and our standard deviation is 1, that we can find the area of the shaded region. So all we have to do is convert this 174 into a z-score that'll put it on this specific curve, on our standard normal curve. So to do that, remember this is our formula for z-score. So we'll take our value, 174, subtract it from the mean, which is 172, and divide by the standard deviation, which in this case is 29. So when I go ahead and solve that, 174 minus 172 divided by 29 gives me a z-score of 0.069. So we get a z-score of 0.069. So if we think about, that'd be pretty close to 0 if we think about it, right? 0.069. So we're looking for this shaded region, right? Everything that weighs less than that z-score. So we converted this value onto our standard normal curve. And now, using the same tools we had last class, we can go ahead and solve for that area. So remember we hit second and then the vars button. And then we went to number 2, which was our normal CDF. And then we type in a lower bound, an upper bound, and a mean and standard deviation. So in this case, right, second vars, go down to number 2. My lower bound, I'm going all the way to the end on this graph. So last time we talked about, to represent as far as we can go, we use -1 e to the 99. Remember, to get e, we just hit second and the division symbol. Then our upper bound is this 0.069 that we found, that z-score we just found. And then our mean is 0 and our standard deviation is 1. So we find that our area is 0.5275. So the probability that a man weighs less than 174 pounds is about 52%. We'll leave it as a decimal, but that would be the percentage, right? Got about a 52% chance that they weigh less than 174 pounds. Okay, well, I'm going to let you in on a little secret. We don't actually have to be in our standard normal curve to be able to find the area. The beauty of our calculator is it allows us to type in any values for our mean and our standard deviation and still find the area underneath our curve. So we're still using that same button. It's just now our mean and our standard deviation are going to change with the context of our problem. So we do not have to convert to a z-score, which is nice. It saves us some time and some rounding errors that may come with converting to a z-score. So let's look at some examples of how we would use this without our standard normal. So I want to know the probability of a man weighing less than 150 pounds. So remember, our mean here is 172. And we're going to practice always drawing these curves so we know what kind of area we're looking at. And then I want a man weighing less than 150. So 150 is on this side of 172 somewhere. We don't have to be super specific on where. We should just know it's to the left, and we're looking for this shaded region over here. So I'm looking for the area or the probability of this shaded region. So we're going to use that same normal CDF that we did. It's just we have to consider what our new mean and standard deviation are. So in this case, my lower bound, I'm going all the way to the end, so it would be negative 1e to the 99. I'm cutting it off at 150. Now my mean in this problem is 172, and my standard deviation is 29. So these numbers are changing when we type it in. So we'll go back to our calculator, hit second vars, normal CDF. Our lower bound is still that negative 1e to the 99. I'm going to 150. Now this is what I change. My mean is 172. My standard deviation is 29. So now when I hit enter, I can still find that same area that I was looking for. So I get 0.2240 as my probability. So it's essentially exactly what we did last class. We're just keeping the context of the problem. We're keeping the mean and the standard deviation of the actual problem. So we're going to have to consider that when we're typing this information into our calculator. So for B, it says a man weighing, I want the probability of a man weighing between 60 and 185 pounds. So again, we'll draw our curve. My mean is 172. So 160 would be somewhere over here. And 185 would be somewhere over here. And I want this area between them. So I'm going to use my normal CDF. My lower bound is my 160. My upper bound is 185. My mean is 172. My standard deviation is 29. That's the context of the problem, right? It said my mean is 172. My standard deviation is 29. So we'll go second vars, normal CDF. My lower bound is now 160. My upper bound is 185. Mean is still 172. Standard deviation is still 29. So then when I paste that and hit enter, I'm looking at a probability of 0.3335. So this represents that area, about a 33% chance that if you randomly select somebody, they would weigh between, randomly select a man, they would weigh between 160 and 185 pounds. All right, so if you feel comfortable, you can try C and D on your own. We're going to keep going over these together just to get some practice, but maybe pause and try these on your own. So a man weighing 185 pounds or less. I always find that drawing the curve can help me know what area I'm looking for. I expect that we draw the curve anyway so that we're aware of the information, but I think it also helps to make sure we know what numbers we're typing in and what kind of probability we should expect, right? I know I should get a value above 50 because I shaded this whole side past the mean. So I'm definitely more than 50%. So it can kind of give us some perspective on what we would expect the answer to be. So then when I do my normal CDF, my lower bound, I'm going all the way to the end on this side. So I use negative 1e to the 99. Then my upper bound, I'm going to 185. My mean is 172. My standard deviation is 29. So that's what I'm going to type into my calculator to find this area. I go to normal CDF. I'm going from negative 1, right, because I'm on the negative side. And then I hit second divide, 99. I'm going to 185. All of that will stay the same. So then I get my area is 0.673, which again confirms we said it was going to be greater than 50, and it is. So we know that we're on track and we're finding the right probability. All right, and then a man weighing at most 200 pounds. So again, we draw our curve. We mark the middle at 172. So 200 pounds would be past 185. And so then we're looking for if they weigh at most 200, that means they're 200 or less. So we're looking at this side of our graph. All right, this is our 200. So we know it needs to be bigger than 67% because we shaded more of our normal distribution. So I'll go back to second Mars. I still shaded all the way to the left on this side, so I'll still use -1e to the 99, but now my upper bound is 200. The rest of my values, my mean is still 172, my standard deviation is still 29, and so now I get an area of 0.8329, which we said would be greater than this, and it is. All right, so it's the same practice we did last class, but just using different values for our mean and standard deviation. A couple things to keep in mind, a couple helpful tips for this. Don't confuse z-scores and areas. Remember, z-scores is a location on your curve. Z-scores can be negative. If you're to the left of 0, your z-score could be negative. Your probability could never be negative. Your probability, your area represents a probability, so it has to be between 0 and 1. That area is the shaded region underneath your curve, and it's always going to be a positive value between 0 and 1. Your z-score has to be negative if it's located to the left of your mean. So any values over here, you would have to have a negative z-score. That represents all the values that are less than your mean. So just keep these kind of helpful tips in mind. There's one more thing that we're going to talk about on the next page. So if you turn your paper over. So we have been given a value and we've been looking for the area underneath the curve. We can also go the other way. That means that we know the area and we're looking for the x value. We're looking for the value that represents the end of that area. So for instance, if I want to know what weight separates the lightest 99.5% and the heaviest 0.5%, right? I'm looking for this x value here. That kind of represents that cutoff weight. So to do this, we're going to use number 3. We go almost to the exact same place. We go to second vars, and then this time we're going to pick number 3. To do this, knowing the area and trying to find the x value, you only need 3 pieces of information: the area that you're looking for, the mean, and the standard deviation. I'm going to talk about this stuff in a minute because depending on the type of calculator you have, depends on if you have this piece or not. So, for instance, let's answer this question. So I know the area that I want is 0.995, and I want to know this x value. I know my mean is 172 and my standard deviation is 29. So I'm going to go to my calculator. I hit second vars. I'm going to go to number 3, NV norm. My area is 0.995. My mean is 172. And my standard deviation is 29. Now, some of your calculators will ask you tail, left, center, or right. Some of your calculators will not. If it does not, your calculator is always assuming that the tail is on the left. That means that the shaded region is on the left. We're shading in the left side of the graph. So some of your calculators can only go off of the left. Some of your calculators are a little more sophisticated and can do any tail or wherever part of the graph that you're looking for. But in this one, we are going from the left, so it doesn't matter which calculator you have in this case. You can type it in just like this, and it tells you that this x value here was 246.7 pounds. So 246.7 cut off was that upper bound here, to cut off the bottom 99.5 to the top 0.5. All right, so let's look at some more examples. The average cost of a home in Denver is $599,742 with a standard deviation of 35,401. What price point would break the bottom 75 to the top 25%? So if we think about our graph, and my mean here is 599,742, and I want to break up the bottom 75%. So this area here represents the bottom 75% or 0.75. I want to know what value here, what X value, breaks up this 75% from the top 25%. So I know the area, I know my mean, I know my standard deviation, so I can solve for this X value. So again, I go to second vars in my calculator. I'm going to go down to number 3, which is my NV norm. My area I'm looking for is 0.75. My mean is 599,742. My standard deviation was 35401, and I'm coming from the left because I'm looking for the 75% on the left. If your calculator does not ask you, it's assuming left anyway, so you're good with what you've typed in. So then I get that this X value is 623,619.61. So that cutoff, that price point would be what we just found. That cuts off, right? If your house is below this, it would be the bottom 75%. If your house is above this, this is the top 25%. Okay. Here's where things can get a little tricky. What price represents the top 10%? So if we think about, we have our normal curve. My 599,742 is the middle. I want the top 10%. So that would be this small shaded region over here represents the top 10%, or an area of 0.10. Okay, so if you have a newer calculator, I'm looking for this value here. So what I can tell my calculator is I want the area, I spelled that wrong, sorry. When I do my NV norm, I'm coming 10%, I want 10%. My mean is 599,742. My standard deviation is 35401. But I shaded in the right of this when I'm talking about the top 10%, right? I'm shading in the right of the graph, so I need to select right. This only works in your calculator if you have the ability to select right, left, or center. So if I put in 0.1, that stayed the same, that stayed the same, but now I'm shaded in the right, then it tells me that that value right there is 645,110.21. So that represents that cutoff score. I went 10% coming this way. Well, not all of your calculators can come from the right. Some of your calculators, if it doesn't let you pick, it's always coming from the left. Well, remember, the area underneath the curve is equal to 1. So if you went 0.1 this way, you would have to go 0.9 this way to get to that same X value, right? We're finding the location on our graph. We're finding that X value, it's a location. It doesn't matter what end we come from, right? If I use 0.9 to represent this area, I'm coming 0.9 from the left, I'm going to get the same value for X. So if I do NV norm of 0.9 using the same values for my mean and standard deviation, but now I'm coming from the left, I'm going to get the same X value. So now I'm using 0.9, same mean, same standard deviation, but I'm coming from the left. And if your graph doesn't let you pick, it's always assuming left. If I solve, I get the exact same value because I'm just finding, right? I just want a different route to get to the same location. So it doesn't matter which one that I pick. All right. So let's go ahead and try the next one. So what price point represents the middle 50% of prices? So if I draw my curve, The center is that kind of annoying number at this point, 4.2. And I want the middle 50%. So this area would be 0.5. So now, if your calculator lets you pick locations, right, I'm looking for now two x values, two values that make up what contains the center. So if I know that I'm looking for an area of 0.5, my mean is, and my standard deviation, if my calculator lets me pick center, I can do this and it will tell me both of these locations at the same time. Let me show you. So when I go to my calculator, second vars, number 3, NV norm, my area is 0.5 because I want that 50%. Mean is still the same, standard deviation is still the same. I want the center, right? My area is in the center now. So when I hit paste, it's going to give me two values. It's going to give me both of these values at the exact same time. So I know that one of them, it goes from 575,864,39 to 623,619,61. Right, so these two values make up the middle 50%. Now, unfortunately, if you don't have a calculator that does that, you can still find it. It's just going to take more than one step because you're going to have to find each of these x values individually. Remember, your calculator is only coming from the left. So if you think about how far to the left do I need to go to get to this line here? Well, if 50% is in the middle, I got 25% on this side and 25% on this side. So I went 25% or 0.25 to get to this location. So if I do NV norm of 0.25, mean is 599,742, standard deviation. And then again, yours is always assuming left. You're going to get that first value there. So 0.25, mean and standard deviation are still the same. I'm coming from the left, and that's that first value that the calculator from the center told us. Same one. So now we just need to go find this x value. Well, if this is 0.25 and this is 0.5, to get all the way across here, I'd have to use 0.75. So when I do that, the only thing I'm changing is this is 0.75 coming from the left, and I get that exact same value here. So it's just two steps, right? You just have to do both of these to get these two values. If your calculator allows you to pick center, you just have to do it once. But remember, if your calculator doesn't let you pick direction, it's always assuming from the left. All right. So it says, what price would have a probability of 0.62? So we're looking again, here's our normal curve. My mean is in the middle. If it doesn't tell me which direction it's coming from, right, a probability of 0.62 would mean it's coming from the left. So it wants to know what kind of value you would get from finding this area here of 0.62. So I'll do my NV norm, and luckily you all get to do it the same because we're coming from the left. 599,742, mean is 35401. And then I'm coming from the left, right? You have to, some of you make sure you specify on your calculator so you get to that correct location here. So then on our calculator, second vars, my area is 0.62, mean standard deviation, coming from the left. And I get that cutoff value is 610,556.33. So that value would give us a probability of 0.62. Okay, so the only thing I want to say, I'm going to have you try these bottom ones by yourself. You can check your answers with the notes on Schoology. The only thing that I want to say is make sure that you're solving for the right thing. If it's giving you a percentage or a probability, then you're using that NV norm that we just did. If it wants to know the probability, then it's asking you to do what we've done before, which is our normal CDF. So for instance, right? This one is giving us a score. So then I have my mean, this is my score. I'm looking for that area. So this would be a normal CDF problem. This one, what score would give us a probability of 0.8 means I know that my area is 0.8. What is that score that represents that cutoff? So then we would be using our NV norm. So just be careful that you're using the right thing when you're doing your work, but you can check your answers on Schoology when you're done to make sure you're feeling good about today's notes.